We wanted to keep maths easy for you, and it was, until we met irrational numbers. But it turns out there is actually no need to panic. Irrational numbers are really easy to deal with. And like what their name suggests, they are not crazy. Even if sometimes they just seem to go on forever. And before we go on forever, let's start this lesson. Remember how we discussed the set of real numbers last time? It acts kind of bossy, ruling all rational and irrational numbers. Now, this lesson is about looking at different numbers to figure out which set they belong to, either rational or irrational. And as a matter of fact, every natural number, whole number, and integer belongs to the rational numbers. But for a quick guess, they are fractions or numbers which are convertible to fractions like 7 or 1.5. And if you are dealing with decimals, then this is something that you should remember. They either terminate or they recur. Great. Now, on the other hand, we have irrational numbers. What's the helping tool here? Two very important points. They are the square root of all prime numbers, or they are decimals that neither terminates nor repeats or recurs. You see any of the two situations? You stamp it as irrational. Deal? Deal. Now, recognizing numbers as rational or irrational should be no big deal for you, because these quick notes must have made you an expert. Let's start with the first example. Now, which type do you think it is? If you thought rational, good job, because 0.25 can be written in fraction form and is also terminating, making it rational. What about this? The number 3 seems to repeat forever. We know this as there exist ellipses, the 3 dots at the end of number, indicating the number continues. That makes it a recurring decimal, and we know recurring decimals are always rational. Not just that, but it's also convertible to fraction too. Just another reason to call it rational. Maybe this one is similar and a rational number too. No? It will be, if you notice the little bar above 3. That means that 3 repeats forever. Now, how about this? Also rational. Sometimes more than one digit can recur, which is fine, as long as you see a pattern. Maybe this one too? What do you say? That's tricky. We can see a trail of zeros and ones. But look closely. Do you notice a fixed pattern of repetition? No. Hence, the decimal is not recurring, making it irrational. Similarly, take a look at the next one. It also doesn't end and does not repeat. The next 3 numbers are irrational for the same reasons. They don't end nor do they repeat, do they? And so is this one. But let's stop here for 1 second. Do you recognize this number? It's pi, the maths kind, not the eating kind. As in, the ratio of the circumference of a circle to its diameter. It's also irrational because it's an infinitely long number. Its 5 lakh decimal places has been determined with the help of computer and no repetition has been witnessed. But as you know, we have to use it for important calculations, like the area of a circle. Hence, for our ease, we approximate it to 22 upon 7. And sometimes even more accurate approximations like this one. That's it for the more straightforward examples. Good job so far. Next, we'll challenge ourselves by proving root 2, 3, and others as irrational numbers. Remember, the numbers may be irrational, but they do make sense. We just need to learn how.